Everybody, hi, how's it going? So let me first, I don't know how to, oops. Okay. Okay, but this is share screen. Okay. Yeah.
Yeah, it's the first time for all our speakers. So if you have technical issues, don't worry. Fine.
That's the usual stuff, and then slide. Okay. Can you see Enzo?
Nope.
Okay.
So if you should have like a share screen and StreamYard, and you can choose a tab or a screen. Now I got it. There you go. Can you switch to the slides? Perfect. I'll remove myself and you're ready to go.
Okay, thanks everybody. And let's start with the talk. This talk is about agriculture, basically, how to prevent bugs with the pesticide. And since we are nice people, we are using organic pesticide and specifically ladybugs. But okay, let's start a bit about our software engineering problems. I suppose that most of you have this idea of quality will cost. And here you can see two cars, which are red. And probably one car is better. I suppose that if you have to choose one of these two cars, you probably won't have any doubts of which one. They have a different quality and a very different cost. And this is how we normally think about cost. I mean, you want quality, you have to pay, which is true, generally speaking, but it doesn't really happen to apply very well for the software development, as I hope to explain shortly. So we were talking about quality. So the normal way to perceive quality, the one that we are used, is that you want quality, you have to pay. So at the end of the day, you have to decide how much quality you afford to pay, and try to find a sweet spot between the cost and your quality. I mean, the top quality that you can achieve. This is definitely working for the manufacturer and other industry, but it doesn't really work like this for the software industry. And if you know this guy, who is called Martin Fowler, he has a very good post and books about this kind of concept, which is that high quality is cheaper to produce. Or in another way, if we have a project with high quality, keeping that project running and keeping the quality high is actually cheaper. It will require less effort than having a project with low quality and just keeping that project working. Because in software, it's different from manufacturer, where basically why a Ferrari costs more than a cheaper car, because it uses better quality materials. But in software, we don't have the problem of materials. And the other point is that Ferrari require more time to be built. Instead, the cheaper cars are done in a way that save time. But that's because once you buy a car, the car stays as it is. In software, instead, we have it to keep changing. So it's a completely different industry. And if you try to cut all the corners that, for example, a very cheap car is trying to cut to keep the price low, it will make much more expensive to change stuff later. And this is why in software actually is cheaper to keep the quality high, which is kind of not intuitive. But then we have to think about what is quality. And there is this book, which is a book that it's very interesting how redefine quality for software. Instead of using some subjective kind of rules or guideline principle, the myth of the artisan, the craftsman. It's very statistical approach. Basically, it's you cannot really measure quality, but you can measure some. They have 4 main metrics: frequency of deployment, lead time for changes. So how often do you deploy in production, and how long it will take for when you have something to deploy to be actually deployed in production. The medium time between release and the change failure rate. So how often you need to roll back a release when because something went. How often do you do a rollback in production, basically? And basically the idea of this book is that you can measure these 4 metrics, and statistically the best company have a very high value in they using these 4 metrics. Basically you can get the better companies, and the company that have implicitly the better code quality. So the idea is that you are not going to measure your code quality in a kind of abstract sense, but using this kind of metrics. So if you deploy every hour or every few minutes, and it takes less than 1 hour to have something from ready to go in production, and also you have a very low rollback, and you take very MTTR is the time required to fix a problem in production. That means that you have a very high quality, regardless of a principle or craftsmanship or stuff like that. So if you have a high quality in this way and you keep the quality high, it will be actually cheap. And to keep the quality high, to be able to do this kind of continuous delivery, and be able to fix any bugs in a few minutes instead of days, there is this. We need an automatic test, and there is this idea of having a pyramid where we have a lot of unit tests, a bit less component tests and integration tests, and less until the manual tests are the more rare. We try to not do manual tests, and instead using QA people to do exploratory tests and not just execute stuff that can be automated. This is all fine, all nice, but to keep the quality high, it's not enough to have the test. we also need to start write the test first. And in the project that I was working on, I'm still working, basically, the architect was Nat Price, who wrote this great book. And he was very keen that you should really write the acceptance test first, because that define basically force you to define what is going to test. So if you are not able to explain from a business point of view what you are going to write, is quite possible that you finish writing some code that is not really doing what was supposed to be done. And so we have this, from the beginning of this project, we have this idea that we need to write acceptance test first. And for acceptance test, we mean tests that are driven by the domain, by the requirement of the business, not from UI or some technical task. And this is more or less our problem. So this is a very high-level view of our microservice system. And these are all these square boxes are all microservices that have to be deployed. Every time there is a commit in production, we deploy. Every time there is a commit on Git, we're going to deploy the microservice in production. So it's quite complicated. And we need to be sure that every time there is a change, we can run all the tests and make sure that the change can go in production in a few minutes without stopping, without breaking anything else, basically. And also, the characteristic of our microservice is that they use the pods and adapter architecture. So basically, all the microservices are defined with the hub, which is internal. And from the hub start all the, they say that in the hub there are the ports, and then there are adapters that connect the hub with all the technical infrastructure. So login, authorization, HTTP, database, and so on. With this in mind, basically, actually, if we look better back, the one with the circle inside, they are service that have the hub inside, because they are doing something that is specific to the business. So they use the port and adapter architecture. The one without the circle inside, instead, they are completely technical microservice. For example, transforming somewhere a document to PDF or something like that. It's completely technical. There is nothing on business side. And so this is the idea of a domain-driven test. That is, okay, we have this nice architecture. We should leverage on this architecture to validate our use case. So we wanted to use the domain to validate the end-to-end working of the application, which is an idea which is quite different from the current framework like a Cucumber, for example, where usually you can write end-to-end test, but you need to use the UI. So the test is very specific to the UI, to the technical, your technical layer. And how we can do this? And the idea is that we have a representation of an actor that should be the abstraction of a real user that tried to do something. And we have two interpreters, basically. One that interprets the actor inside the domain, which is the arrow, I don't know what is mauve arrow, and the blue arrow, the purple arrow, and the blue arrow is that instead is the HTTP interpreter. So whatever the actor does, it uses HTTP to translate. And in this way, we can describe the problem as a domain, but we can also execute as a and fully end-to-end test. And when you have a multiple microservice, it's the same thing. So the running the test twice. The first time I only use the hub, that is the internal of the hexagon. And the second time I use in HTTP, HTML, end-to-end, putting all together. And in this way, every time we have a small change, we can verify that everything works, basically, before putting. And writing this kind of test is actually quite fast. So this really allows us to deploy continuously and be confident that we are not breaking anything. Basically, my working on this, working with Nat, I came out with this idea. Okay, we can make it a bit of leveraging on Kotlin DSL, because it's very nice language. We can make this stuff a bit more fun to use, a bit more simple to set up. And I wrote this. It's a very small library that makes easy to use this kind of testing, DDD. And you can find on the GitHub, basically. And I will try to show you now. So this is a bit more specific. For example, we have steps, which are action that the actor does. So one actor can be add an item. And this item, this action, this step, basically got transformed in the HTTP interpreter in some HTTP call, then check back at the application status. And this is an item that actually changed the state. Some other steps instead are steps that assert that the state is in the way we expect it to be. For example, get items. And in this way, we write the step only once on using domain terms, domain word, and then the interpreter will translate in HTTP calls. But then the assertion will be done on the actor side, because the assertion will be a domain assertion. So we expect that the items are exactly the items that should be there. And the test itself completely is unrelated with the technical implementation. If we wanted to change the technical backend, we needed to change the HTTP interpreter, but we don't need to touch our test. And using this kind of flow with the DDD also help us to guide in the design, because we start every time there is a new feature to write the HTTP DDT, and this will kind of nudge us to write a good design, something that can be tested, and to do the implementation. Once we have the implementation at the end, we write the unit test for the details of what we need to write the code to make this stuff working. And when today is a very bad day. When we are at the so first we define the HTTP calls, then the memory DDT. Finally, we write the actual code, so we can write the unit test. This will make the memory DDT work, and then finally we wire the final things to make the HTTP DDT work as well. So in this way, also it really give you a good pace to implement each feature. And now let's see exactly the test. So this is actual code from our production, so it's not an example. In the GitHub repository, there are some examples I will show you, but this is from our production. and we are defining a flow for academic journal. And you see that this is the test, basically, and the test define what the author of a journal basically have to do to approve his article, basically, and his license. But this is very clear, like in English, because it's clear. And it's something that anybody can read and understand how the system works. So they also work a kind of documentation of the system. All the technical assertion, all the domain assertion are inside the actor. So the actor have this role as a kind of container of all the technical mess up that is needed, but that we don't want to see in the test itself. And when you run basically this test from IntelliJ, this is how it looks, because every test run twice, first in HTTP and then in first in domain only, and then also in HTTP. And all the this is a bit of the framework that I wrote. Basically, it also substitute the name of the variables in the test name. So it's quite easy to read as well. And now I would like to have a coding demo, if there are no other problems. And so basically, this is the project that you can get from GitHub. Core is the actual library. And then there is another module with examples so that you can use as copy-paste inspiration for your actual project. And there are also some examples in Java, because the library is written in Kotlin, but also works for Java. Only that the DSL is not as nice as it is in Kotlin. And for example, this is a kind of because the DDT have this idea of a setting. It's a bit like you have a play, basically, in a theater. So you set up your actor, you set up your background, and then you let the actor do the script, basically. So I say, okay, let's do an example with a fable, with a Little Red Riding Hood. And we can see here, basically, this is the main story. So Little Hood goes in the forest. So first, let's put the forest with a grandma living alone inside. And this is the setting part, which is not part of the test itself, but prepare the system. And then authorize, basically, this is the actual test. And then we can say, Little Red Hood go to with the basket, go to the forest, then get the big bad wolf, and so on. And we can also say, okay, let's do another scenario where basically Little Red Riding Hood avoided to tell the wolf about where the grandma lives. So if we use this scenario, at the end, everything goes well and nobody gets eaten. But we can also have a scenario without the hunter, basically. So the big red wolf eat the girl, and there is no hunter. So that's it. I mean, Little Riding Hood cannot jump out of the bed, and they cannot give the good to the mother. And you see, it's quite expressive if you write well, and then you can just run it from IntelliJ. And you can see here that there are the three scenarios: normal, wolf win, and smart girl. And in this case, it's only domain only, because we don't have an HTTP application. But you can see that each single step gets translated in a test, an individual test. And if it fails, basically, you can just jump directly where it failed. For example, if we wanted to make that a different value for the goods when we run the test will fail. And you can see that the test is failing. And then let's do another test. Let's fix this one. Which is a bit more complicated test. This pet shop test is a real, it's a kind of an application. So there is an actual REST application that works as a pet shop. And so at the beginning, we needed to specify that the interpreters that we are going to use, which are two, but can be also more than two. For example, if you wanted to have an HTML UI with the JavaScript interpreter, for example, on the top. And also another thing that I should probably say is that the HTTP interpreter, it's using the host. In this case, it's using the local host. But in our system in production, we are using the staging and the actual the test environment, basically, to run the test. So not only we can verify that everything works locally, but we can also verify that works in the test and the staging environment. So in this case, for example, here is this idea of the hub. So this is our hexagonal architecture. And this is the domain-only interpreter. And the domain-only interpreter just needed to know one hub or more than one hub if you have a microservice. And translate each command directly in a command for the hub. So it's quite small and very simple. The HTTP interpreter instead needed to translate each command in a command to the server. So at the beginning, you have to prepare and actually start the server. And then it will basically translate each request, each command in a request that goes in HTTP, and then at the end verify that what's happening is what should be happen. And so this means that in the main, you see that there is actually a pet shop, which is with the full main, and you can start is a kind of REST application. And also the interesting part is how we write the test. And to write the test, basically, we define the actors using, this is a bit of DSL, but this is the actual actor. So in this case, it's a buyer of a pet. You can define a name, and then you can define which kind of actor is, basically, in this case. And everything that the actor does is defined as a step here. So you can see something, then step, and then you define what is happening in the step. So when we can write a test where basically the shop assistant check the pets, because shop assistant is another actor with a different type. So it can do different things. And in this case, for example, there are two. First, we set up the shop with the two pets. And then we can check, the shop assistant can check that everything is in order. But then we can also have a story where Mary buys a lamb, and we set up the shop with the lamb, and then Mary can check the price of a lamb or of an hamster, and then decide to buy a lamb and check out with the pets, and so on. And it's quite simple to write a new test for new scenarios. And if you have a question, I think you can do at the end, and I will answer. So let's go back to the presentation. If I found, yes. So wrapping up, what is the takeout? So domain-driven test help us in this way. We use the domain, not the UI, to describe the scenario. And we run the test multiple times to verify different abstraction level. And then we can express expectation at higher level, meaning that we are not just checking click here or click there, or to verify that this box is green, but we can define expectation as a domain language. So the benefit is that we can test the feature end-to-end. We can document how the story, the feature should work. We make sure that there is no logic in the infrastructure layer, because if someone puts some business logic in the infrastructure layer, the domain-only test cannot pass, basically. And also we make sure that there is no infrastructure detail in the business logic. So inside the hub, everything must be very pure, very defined as a business. And all this rule is not making harder for us to develop, but actually they give us speed at the end, because we can change things very quickly, because we are completely confident that our automatic test will detect any errors. And also it's quite easy for us to add the new errors or new logic. Sorry, new test or new logic. And this is basically how the process. So first we write the HTTP DDT, then we implement the adapter, so the external shell, basically. This will give you some hints how to define the model to solve the problem. So then we can write, once we define the model, we can write the in-memory DDT, and then we can close the gaps with the HTTP communication if there is anyone. So that this is my social media handles. If you wanted to ask me a question or read, there is in my blog there is a post about this, and you can follow me on Twitter, and now you can ask me questions.
Okay, I think we don't have any questions. Just one comment about the 4 matrix in the YouTube comments. They say, as far as I know, those 4 key metrics from Accelerate are not leading metrics about quality, but about business performance, as they translate to IT agility. Good metrics to have nonetheless.
But that's exactly my point, that my concept of quality is business agility. I don't want another concept of quality that is different from this one. I mean, I cannot measure the internal quality of my code directly, but indirectly I can use using this business agility, because if my code allows for business agility, that means that my code is good. And apart from that, I don't care basically how I can get my code is good if it allows for business agility. I'm completely fine. This is my point.
Cool. So if there are no other questions, me say thanks to you, Uberto. A very nice talk, and thanks for being here.
Okay, well, you're welcome.